Okay, let's spend a few minutes talking about probability models, which are just ways to predict what's going to happen in the real world using probability. So quick probability review here. We know that probability is about understanding the sample space, all of the different events that can happen, and then the ones that you're particularly looking for. And we can calculate probability using math by saying the P, probability of an event, we put it in parentheses here, is the number of times the event occurs in the sample space divided by the total number of possible events in the sample space. So let's use a probability model here to take a look at this problem. A cloth bag has 3 green marbles, 2 blue marbles, 4 yellow marbles, 6 red marbles, and 5 purple marbles. If you draw one marble 10 times, replacing the marble each time. So you're not going to look, you're going to reach in the bag, you're going to pull out a marble, you're going to see what color it is, then you're going to put it back in the bag. How many times would you expect to get a marble that is not green or blue? Okay, this is kind of an interesting kind of a probability. It's a not probability. So we can set up our equation here. The probability of not green or blue. So remember, P just means probability, and then we put the event that we're looking for, not green or blue, in parentheses here. Okay, so first of all, what's the total number of different possibilities? What's the total number of events in the sample space if we're going to draw one marble? Well, let's see. There's 3 times that it could be green, 2 times it could be blue, etc. So if we add all these numbers up, 3 plus 2 plus 4 plus 6 plus 5, let's see, 3 plus 2 is 5, plus 4 is 9, plus 6 is 15, plus 5 more is 20. So the total number of events in the sample space is 20. And now, what's the number of ways that we can get not green or blue? Well, this doesn't count, the 3, because it's green. This doesn't count because it's blue, but everything else counts. So 4 plus 6 is 10, plus 5 more is 15. So 15 out of 20 is what our probability is. Make sense? Now, you can simplify that fraction. Can you think of a greatest common factor for the numerator and denominator? Yeah, it's 5. So that 15 divided by 5 is 3, and 20 divided by 5 is 4. So that simplifies down to 3/4. And we could keep the probability as a fraction. We could turn it into a percent, but just for ease of math here, let's go ahead and turn it into a decimal. So 3/4 is the same as what percent? Yeah, 75% or 0.75. Okay, now when we actually make a prediction, remember we're trying to figure out if we were to draw it 10 times, how many times would we expect? Well, the prediction here, we just multiply that probability of 0.75 times the number of times that we're going to do the experiment, and that's 10. And you know that 0.75 times 10, you just move the decimal place when you multiply by 10, so that's 7.5. So you would expect to get a not green or blue marble 7.5 times. Of course, you can't get it actually 7.5, so you might expect it to be 7 or 8. Now, let's say you did the actual experiment and these were the results that you got. Okay, so how have I set up this table? And this is what you should do when you have an experiment, is set up a table. Here's which attempt it was. Here's the color I got. And then we put whether or not it meets our target event, because our target event is not green or blue. So blue, the first time, that does not meet our target event. But yellow is not green or blue, so we put a yes. Purple is not green or blue, so we put a yes, etc., etc. And you can see that 1, 2, 3, 4, 5 times we got the result that we wanted. But that's a little bit different than 7.5. So what's going on here? Well, there's a couple of observations you can make now about probability models. The first one you already knew. Probability models often don't match experimental results exactly. Okay, so you should predict with probability, but understand that it could be a little ways off of your model, and that's natural, that's expected. And then a second observation here, we only pulled 10 marbles out. If we'd pulled 1,000 marbles out, it would be a lot closer to the predicted result. So the second observation here is the fewer number of attempts in the experiment, the less likely the result will match our model very closely. Okay, so that's how you use probability models.